the rise in sea levels worldwide. Since the late 19th century, we have seen a dramatic departure from 2 millennia of relative stability in the way the world's oceans behave. This shift, related to the beginning of the Industrial Revolution, is one of the most important signs of global climate change. By looking at the history and the physics that drive this, we can better understand the urgency of rising sea levels in today's world, which is now May of 2026. Turning point of industry and historical stability. Earth's oceans have had an astonishingly stable level for the past 2,500 years, offering a reliable base for coastal development and ecosystems. This period of equilibrium came to an abrupt end around 1863. According to scientific studies, this specific period is associated with the earliest signatures of anthropogenic influence over the climate. Humans grew increasingly dependent on fossil fuels, and the resulting changes in the atmosphere set in motion a series of environmental feedback loops. The present state of affairs is a preamble to the late 19th century. Prior to 1863, the interaction of the ocean and the atmosphere was in a state of balance. However, the following warming of the oceans and the first retreat of the glaciers showed a fundamental change in the hydrological cycle. This historical context is important because it shows that the current increase is not a normal variation, but an anomalous acceleration due to human activity. Physical processes of ocean widening. To understand the complexity of rising sea levels, we need to look at what mechanisms increase the volume of the ocean. Scientists emphasize this is not a one-off event, but a combination of several dynamic factors working in tandem to push water onto our coastlines. Thermal expansion processes, water molecules expand as they take up more room than they did when the environment was cooler. The ocean absorbs the great bulk of excess heat trapped in the Earth's system. Glacial melt contributions, the release of large volumes of fresh water through the widespread retreat of mountain glaciers, is leading to fundamental changes in the water density and total mass of the global ocean. Ice sheet decay, the fastest loss of mass from the Greenland and Antarctic ice sheets, poses the biggest threat to long-term sustained sea level rise, as these huge stores of frozen water are becoming increasingly unstable as a result of global warming. Measuring the acceleration. The tale of sea level rise is a story of ever-quickening pace. Global average sea level has risen about 8 to 9 inches, or about 21 to 24 centimeters, since 1880. Alone, these numbers might not be that big, but the rate at which this increase is happening is the most alarming aspect of the data. We have moved from a period of stability into a period of runaway acceleration that pushes our adaptive capacity. Satellite data through 2023 demonstrate that the rate of rise is not only increasing, but compounding. The rate of increase was relatively steady during the 20th century, but recent studies covering the 2006 to 2015 period show that rate doubling. Between 2013 and 2022, satellite altimetry has documented the highest global average sea level on record, increasing at a rate exceeding previous projections. This trajectory means we're entering a phase of rapid environmental change which requires urgent scientific and structural attention. The prevailing fashion is to regard. With the date being May 3, 2026, it is evident that the trends established in the late 1800s have only intensified. The data collected by organizations such as NOAA is a crucial warning. This shift from a stable multi-millennial phase to a modern period of swift ocean expansion highlights the tremendous effect of global warming on the physical features of our planet. The 1863 threshold, the year 1863, is the statistical tipping point at which the long-term stable baseline of the global ocean was broken. The 1880 baseline, this is the critical reference point for modern sea level monitoring, giving scientists the ability to measure the cumulative effect of roughly 146 years of climate change. The 21st century rise, the latest data from the last decade, shows that the present rates are unprecedented in the context of the last century, emphasizing the need for adaptive infrastructure. Implications for the global society. The implications of this data go far beyond academic research. Rising sea levels threaten to inundate coastal infrastructure and port cities and to wipe out low-lying island nations. Because the ocean warming and ice melt processes possess a significant thermal inertia, the water currently being released or expanded today will continue to influence sea levels for decades, if not centuries, to come. It's not just about the numbers, it's about recognizing the physical realities of a changing world. The acceleration seen between the 20th and 21st centuries is a clear mathematical warning that the systems governing our climate are changing in ways human civilization has never had to deal with before. This knowledge is essential for policymakers and citizens alike as they plan for future stability in an increasingly volatile climate. To put it simply, we have moved from a stable historical baseline to an era of rising oceans because of human-caused climate change. In recent decades, the rate of sea level rise has doubled to record highs, driven by thermal expansion and melting of polar ice